All right. Hi, everybody. Welcome to another AWS Michigan Meetup. Thank you for joining us, even with the rain going on. It's been really wild. I'm Joe, Business Development Associate here at Right Brain Networks. Today, we'll be having Ritesh Shah talking about faster with low, no-code AI and machine learning from AWS. So it's going to be a really interesting topic. Just refresher, same as always, we've got our catch box here. So if you guys have any questions, you know the drill. You grab the box, you talk into it just like this, and everybody can hear exactly what you're saying, but you got to talk into it like that, and then it's nice and soft. Talk it, whoever else has a question, and we should be good to go. So without further ado, please welcome Ritesh Shah.
Ready?
Oh, this cord's here. You know what? There we go. I'm slightly nimble still.
All right, good evening, everybody. Thank you for those who are here. I'm Ritesh Shah. I'm a Customer Solutions Manager at AWS. My job is to be a migration advisor for our customers to make sure they're successful in the cloud journeys. I basically make sure that they get the value they're expecting out of cloud. I'm very passionate about AIML. And to give you a couple examples, for one of our FSI customers, I helped them reduce the customer churn. We developed a model. We went through the whole ML lifecycle. And even if they save 1% of customers from leaving them, it would add up to $2 million to their bottom line. Another financial services customer, they provide loans, and they developed a model to even predict who's going to pick up the collections call. And they're going live this week, actually tomorrow. And again, the power of 1%. If they reduce default loan rates by 1%, that adds $11 million to their profitability. So I just enjoy doing this type of work, and besides that, I love talking to people like you. This is going to be collaborative. I'm hoping to learn as much from you guys and your experiences as well. I'm sure nobody's here for food, but we're going to have fun together. With me here, not here, but virtually, I have my partner, Nick Lawson. We'll see if he can unmute himself and do a quick intro.
Hey, Nick. Do you want to go ahead and introduce yourself?
Sure. Can you hear me okay?
Yep.
Perfect. Hey, everyone. My name is Nick Lawson. I'm a solution architect here at AWS. I'm also part of our AIML specialty group. I'm here to lend a hand to Ritesh tonight, and I'm also running the lab next week.
Awesome.
Awesome. Thank you. The live stream's going to start in a sec. It's just delayed from YouTube. So thank you.
Alrighty.
Yeah,
Thank you, Nick. Quick agenda. So we'll talk about a little bit of low code and no code offerings that we have through our SageMaker service. I will try to minimize slides and try to show you some demo. It's going to be a cooking show, a little bit, just so that it is real for you guys. So that will be kind of the first hour, and I have 4 services or tools that I want to show you. And then, with all the hype around generative AI, and Adam gave a couple bright ideas about how we can use it just before we were starting here. So I'll talk about what we at Amazon think about generative AI, where we see our customers going, and stuff like that, okay? And then I want to leave some time for interaction. During the whole presentation, if you have any questions, in person, just feel free to ask. And if you're on the live stream, put it in chat. I think Joe or Hannah will do their best, and I will try to respond as we can, okay? Nick briefly mentioned, we are doing this meetup a little bit different, so we're doing a presentation today, and then immediately after a week, I think June 22nd, we will have a hands-on lab. Nick is going to lead that. I will support him. We provide AWS accounts, and we give you all the lab instructions and everything. It just gives you hands-on practice and makes it a little bit real for you guys, okay? Okay, with that, before we get started, how many of you are you do ML, is your day job, or you're new to ML? New to ML? New. Okay, yeah, so this presentation is going to help both audiences. So if you're brand new to ML, I'll try to walk you through the life cycle and keep it simple and basic so you learn something new today. But those who are, doing ML every day, the data scientists and ML engineers, I'm hoping you will get some tools that will make your experimentations faster than you normally do, organically do it today, okay? So let's talk through what a typical ML workflow takes, right? So data has the gravitas, so you got to start with data. So the first step is identify your sources, get your data into AWS, clean it, prepare it, do feature engineering, make the data ready for the ML models, right? The next step is you start building the model, which is essentially writing a script or a mathematical formula, that can predict the trends even for unknown inputs and give you an output. You got to train the model and tune it. And when I say train it, is basically give it lots of examples. So if you are trying to do like identify what's in a picture, you give it lots of pictures, and some of those have to be labeled in the beginning when you're training. So this is a cat, this is a dog, this is a human, and different. That's what it uses to learn and create a mathematical formula. And then when you give it an unknown picture, like something in this room here, it'll tell you whether it has a cat or no, right? So that's essentially what training and tuning is. And then once you feel comfortable, when you think the accuracy is good enough with your validation data, you deploy and then monitor it, right? So that's what it takes for the whole ML workflow. Now, if you think about the complexity, you require deep expertise in your domain and your data and your business, right? You need to do a lot of experimentation with ML because there is not a easy way to know, okay, this model will work for this use case or that model will work for that use case, right? You have to know which model to pick. Once you pick the model, you have to know the hyperparameters to tune that model, right? And I know I'm kind of throwing some heavy words if you're new to machine learning, but every model has some knobs, and then there are a ton of them, and you kind of have to know them to get you the best output, right? It is complex. And even if you're a seasoned data scientist, it involves a lot of experimentation and a lot of time and a lot of money and a lot of compute and a lot of resources, right? That's why we have the low code and no code to really make it simple. So even if you don't have ML experience, as long as you just know the basics, you can get started pretty fast. So I'm hoping when you leave today, you have some tools in your toolbox that you can even go and use at work, hopefully. Yep, so this is what we've heard from customers. So I was talking about an FSI customer, right? They were building the customer churn model. They actually went live in about 12 weeks. One of the big reasons was because they used some of the features or services that I'm going to walk you through today to make those months of effort into weeks, right? This is a very busy slide. I'll try to go slow. So at the top here, you have the 4 phases that we talked about. For the very first phase, we have Data Wrangler. So again, it's a drag and drop visual interface for you to import data from the S3 buckets or Redshift, or even from outside like Snowflake or Databricks or other sources. Then you can visualize the data, analyze it, prepare it for actual machine learning. So that's what Data Wrangler does, okay? And I'm going to show you a demo so you understand what it is. Then you have autopilot, which is like you have autonomous cars, you have autopilot, so you don't have to know much. You just give it the input data set and tell it what column you need predicted, like what you need predicted. And it will automatically identify the model, train it, optimize it, and make it ready for you to deploy it, okay? The third one is Jumpstart. So machine learning model development is complex. So Jumpstart basically offers a set of pre-trained models that are ready for you to use, right? Like everybody uses ChatGPT. Essentially, under the hood, they all use foundational models or large language models. And Jumpstart gives you those to get started so that you don't have to do all of that training from scratch. All you have to do is just give it your business data and make it intelligent for your domain so it does what you need it to do for your business and customers. So these three things, I'll try to show all of them in the tool today, and these are kind of low-code options, so they're drag and drop, but it also generates code that you can use to make it, to improve it, make it better, and enhance it. We also have a completely no-code option. We call it Canvas. It does the full life cycle. So you give it kind of works like an Excel sheet. Like you feel like you're working on an Excel sheet. So you just give it data, it does real machine learning and gives you the output you expect, okay? Alrighty. So what is Data Wrangler? As I said, first step is importing the data, and we have lots of sources. Then you visualize it, then you clean the data and prepare it for machine learning. And that's it. Once your data is ready, by the way, this whole process of converting raw data into features that machine learning can consume is typically called feature engineering, right? And that's what Data Wrangler does. So once you do your feature engineering, a lot of organizations, mature ones, they don't want to keep doing this for different models and for different teams. So they want to save this work into something we call as feature store for reuse. So you have some raw data, you make it, you enrich it, and you convert it into a feature that ML models can consume. You save it in feature store, and so the rest of the organization can use it for other models, okay? Alrighty, with that, I would like to start going into code, okay. And I'm gonna turn myself, is that okay if I turn a little bit this way?
Yeah.
Okay. So, I am basically logged into my console. This is basically AWS console. I'm into SageMaker, and then I open the studio here. So when I open the studio here, this is where it takes me. Can we make this bright? Or is it okay for everybody?
Is your computer brightness up a little bit? I don't know.
You try turning off the front lights or turning them down or something.
Yeah.
My display is,
I'm not sure why it got so dark.
okay.
A little too dark, Jamie?
Yeah, cameras aren't gonna work like that.
Okay, I'll try.
Yeah, that's a bit better. Maybe?
Okay, so I'm in the studio, and if you scroll on the left-hand side navigation, you see Data Wrangler. And the very first step is basically importing your data, right? As I told you, you have these different, if you're familiar with AWS, S3, Athenas, and Redshift, or whatever you use in AWS, but also external sources like Snowflake and Databricks. And I showed you a lot of other sources that we have as well, okay? So once you import the data, next step is you basically want to start looking at it. So for this demo, I've kind of imported some sample Titanic data. And it's very hard for me to see. Okay, I'm going to use some sample data here. Okay, I'm going to be back to slides. This is being too hard for me to navigate. Sorry about that, guys. Okay, so we were looking at how to import data. So the first step is importing the data, and I talked about the different sources. Okay, so as soon as you import the data, right in that console, I wish I could show you, you can start visualizing your data. So I had taken the Titanic example. So it had data like, what was the age group, which cabin they were in, how much tickets, like what was the amount they paid for tickets and stuff like that. And the output that we were trying to predict is, did they survive or not, right? So that's just sample data. So input data was all the attributes about that passenger, and then output is whether they survived or not. So you could look at, so survived is the target column that we are trying to predict in that data. So for unknown data, you want to know whether this passenger survived or not. So you can visualize each of those attributes, like some of them are true, false. So what was the age, like, or whether they were a male or a female, right? So those would be true, false values or 1, 0 values that you can visualize this way. You can also create histograms. So the point I'm trying to make is when you have tons and tons of data for machine learning, you need an easy way to really visualize the data so you can make sense out of it and get a feel if it is ready for machine learning. And this lets you do it with quick UI and drag and drop interface. The next step you typically have to do is transform your data and make it ready for machine learning. So as an example, machine learning models typically understand 1 and 0, right? They like to work with numbers. So if you have sex as male or female, you have to convert it into 1 or 0s. One of the very common ways to do that is one-hot encoding. So you basically have a column male. You just break that sex column into 2 columns, male and female. When it was a male, you put a 1 and 0 for a female. If it's a female, you do the reverse, right? So that technique is called one-hot encoding. Typically, you would have to write code to do that. Once you get your data, tons of data, you would have to write code to do that. With this, we have drag and drop options to just use these 300 built-in transformations that you need for machine learning. So I gave you a complex example, but there are simple examples. Like if your data has missing values, machine learning algorithms don't work well with it. So you kind of have to impute those missing values, and there are ways to just do that. Easiest way could be just dropping those complete rows altogether, but that may not always be the best thing to do because if you're just it might just make your data a little bit more biased, right? So you might have to impute it sometimes. So you could see here there are just ton of different. So when you're doing machine learning, you have to do all of these things for each of those. So I gave you an example of sex. Another example is age. There could be so many variations on age. Typically, you want to group them and bucket them into, okay, 0 to 10, 10 to 20, 20 to 30, right? So those type of techniques can be easily done through these transformations that are built in Data Wrangler. Even better, like even, you look at all of the data, but it also gives you a prediction of how accurate the model will work with the data you are supplying. So it does all of that analysis and gives you that outcome. The other things it does is bias analysis. So if in your data, if you have a lot of entries that are for male and very few for female, that introduces some kind of bias for your machine learning algorithm. So Data Wrangler will identify those things and tell you up front. The other thing it does is there a correlation among attributes? So for example, the boat that they were in and the amount that they paid for their tickets. Depending on the amount you pay, you get a certain cabin or a certain boat, right? So those could be really well correlated, and you don't need both of them to determine, which one was important for the passenger to survive or not, or predict whether they survive or not. So you kind of need to reduce the attributes where you can to improve the model accuracy, right? So all of that typically is a lot of code, and with Data Wrangler, you could just do drag and drop. Yeah.
How do you know which transform to do? Depends on the. How do you know which transform to do?
It depends on the data. So like I said, if you have like values like sex, male, female, you one-hot encoding converted into 0 and 1. Age group was another example where I said, you don't need all the different values of age. Like anybody less than 10 or anybody less than 16 probably you want to use should mean the same thing. So you just bucket them and group them. So that's where you would use that transformation. If you have missing values, like I said, that's another transformation because machine learning algorithms do not do well with missing values. They need all the values filled in, right? So it really depends on your data and also the algorithm that you're trying to use. Okay, so once all of this is done, it generates all of this code that you can enhance it, or you can also integrate it into your SageMaker pipeline for the rest of the machine learning workflow, okay? So it really integrates very well with SageMaker, with all the other features that SageMaker offers. Alrighty, I was hoping to do a demo, but okay, and this is Deloitte is one of our customers. They've used Data Wrangler. I talked about another FSI customer where they use Data Wrangler to import data from Snowflake. And in about a week, we were able to get all the data, clean it, prepare it, and make it ready for machine learning. And that's why they were even able to go live with their customer churn model in 12 weeks. Okay, moving on to the next one. Autopilot. So really, for autopilot, after you're done with the data preparation, you need to give, generally from the data wrangler, you might want to put your data into S3 bucket. For autopilot to work, all you need to give it is, give your data set, and what is the target value that we are predicting, right? What is the output that we are expecting? So in our previous example, you give attributes such as which cabin they were, what was the age, what was the sex, and the outcome that the model was predicting is whether they survived or not. Another example is if you have, attributes for a house, so how many bedrooms, square footage, location, etc. So these are all the input attributes or data, and the output would be probably the price of the house, right? So all you need to give it is the data set for training and the target attribute. Rest of the thing, it does automatically for you, right? And not only that, it basically does the feature engineering, model tuning, and training, and it gives you the entire code as an output or an artifact called models that you can deploy it into your production workloads. It also gives you explainability, which is very important. So if you were a data scientist, your business would ask you questions like, why is the model predicting this way, right? Why is it saying this person survived? So explainability would tell you which attributes have a higher impact on the output that it is predicting, right? So for example, if I go back to the house example, the location and maybe the square footage of the house has the highest impact on the value, right? Number of bedrooms might be same or correlated to square footage, and that may not be having that much impact, if you will, right? So that's what is explainability, and it gives you that automatically. You don't really have to do a lot of work and analysis for that. Otherwise, data scientists spend a lot of time doing that. It also generates metrics. So in the machine learning world, there are different metrics to predict the model accuracy. How many false positives, or how many true positives, how many true negatives, how many false negatives, and stuff like that. There are metrics like recall and precision, which it automatically calculates for you. Okay, so using autopilot is really simple. All you need to give it is the name of the experiment, tags like anything else, the location of the S3 bucket where the data is, and what is the target column that you're predicting. And then click the button and it does the rest for you. I'm going to just try one more time to see if I can show you AutoML. Okay, so we have AutoML here again in the studio. If you want to really create an AutoML experiment, you click here. I'm going to just give it a name. I will give it the S3 bucket where the source data is. Okay, so if you see, this is the data that I was talking about, Titanic, right? So survived is the target column we are predicting. So 1 means this passenger, Elizabeth, survived. 0 means Helen did not survive the Titanic, right? And these are the other attributes that were used, like the cabin, the fare, the ticket price, etc. So I just select where the data is, like the S3 bucket, and then the next thing I do is, what are we trying to predict here? So in this case, we're trying to predict who survived. In your loan default, you will predict the loan status, whether it's paid off or default or charged off or things like that. And that's it. And then you just start training it. So I would leave it auto, so it does the rest for you. And that's it. You just go for deployment settings. I'll say I don't want to deploy it for now. And then done. So now it'll automatically do the training, and you can see here it's doing the trainings, generate the reports and deploy the model. Typically, if you are a data scientist and if you try to do all of this with code yourself, it is weeks or months of efforts. And you don't get the expected outcome in the first attempt. You have to go through multiple trials and experimentation. You have to use lots of compute, lots of time. So this really makes it fast and easy for you to give you an initial boost. Now, a lot of our customers would take this as a starting point and build on top of it. So you don't have to essentially go live with this model. You can do other things to make it better as well, right? So you get access to all of the code and stuff like that. So while that is running, I can just show you one of the existing ones that I ran. So if you look, this is something that I had run before, and it tried these many models, okay? So if you were to try each one of these, it's a lot of effort, but it tried all of these for you, and it told you this one is the best one. These are the different metrics that are used in machine learning world to know how accurate the model is. I don't want to go into the technical details of each one of them, but if you're new to machine learning, each one of these numbers, if it is closer to 1 for most of them, it means the model is accurate, okay? So it is predicting that this one is the best model here. It's giving you explainability. So out of all the features or the input data that we saw, both in male or female, I'm surprised why name has importance, but both and male and female and age had a higher impact on predicting who survived or did not survive. And this is all fake data, so don't go by it. But if you had real data, it'll tell you which attributes are the most important for the predictions. It'll also give you, before I jump there, these are all the parameters. A lot of these are the knobs to fine-tune the model, and it'll tell you which ones to use. So you don't have to try all of these. In real world, each one of these would have like different values, and you would have to, turn the knobs to make sure which one is the best. It does all of that for you. Okay, we looked at the performance. Just to give you, this is the actual label, and this is the predicted label. So actually, the person survived versus what did the model predict, right? So if it is a 1 and a 1 means the actual value matches the predicted, means it's accurate. 0 and a 0 means it predicted accuracy. So this tells you how accurate the model is. And then all the code that was generated, it dumps it into S3 buckets, and these are the URLs. So you have it. It's basically tar.gz files that you will have access to, that you can use or improve upon to, for your production workloads. I hope it is making some sense. I know a lot of you are new. I'm trying to simplify it, but if you have questions, feel free to, ask me. Okay. Okay, we talked about the performance. I told you it's completely white box, so you get access to the code and everything, so you can even enhance it. Alrighty. This is the customer that used Autopilot, but the other FSI customer that I talked about, they had, before we started helping them, they had already tried a couple models like XGBoost, etc. But they were still unsure which one is the most accurate. So our suggestion was, let's start with Autopilot and see which one it recommends. So we did that. In about half a day, we had what the recommendation was. And then they had done a couple of trials. So then we had 3 experiments, one from Autopilot and 2 that they had tried to identify the best one. And by the way, as I showed you, Autopilot already tests like 5 or 10 models. It's not just 1 or 2. Okay. The next one is Jumpstart. So Jumpstart is simple. Like, as I said, having these models or developing these models from scratch is typically very, very complex and time consuming. Especially if you think about the large language models that are coming up for ChatGPT and things like that. You have to put a lot of GPU, you have to put a lot of data for training, a lot of hours, a lot of parameters. So Jumpstart really gives you a jumpstart, like it says. It offers a pre-trained set of models that you can use. All you have to do is give it your organizational or your industry or domain data to make it useful for your use cases, right? They do like a lot of things, and we're going to talk a little bit more when I talk about Gen AI, but essentially, in short, I know a lot of you are new, so I'll just keep it simple. It gives you foundational models that are pre-trained, that you can, it's just like a package that you get ready to use, easy plug and play. Alrighty. Canvas. So the 3 options that we talked about were low code, so although they're drag and drop, you still have access to code and make it better if you need to. Canvas is completely no code. So Amazon or AWS, we strive to democratize machine learning. So we want to make it very easy and make it available, distribute evenly as much as we can. We don't want it limited to large organizations or governments who can afford it. Even if you do not have machine learning skills, Canvas just behaves like it's an Excel spreadsheet. You just give it data, tell it what you need predicted, and it automatically does the rest for you, okay? So that's essentially aimed or targeted for business analysts, okay? Some features, so it behaves like a SaaS tool. So you get a completely different URL that you can use, even if you don't have to essentially log into the console, you get a different URL that you can use. It does, the feature engineering that we talked about. It selects the model, it has built-in AutoML, so it will train and tune the model and give you the output. If you already have like other machine learning technology that you use, we've seen our customers find this less expensive, and it reduces their overall TCO. It also takes away all the heavy lifting that you need to manage the on-premises infrastructure for all of the on-premises tools that you have. I'm going to try to go to the tool and show you so that it makes a little bit sense. Okay, so here up until now for the low code, we were in the studio, and from studio I went to the data wrangler and AutoML. Now I'm going to use the canvas. Okay, if this works, I want to make it a little bit real for you guys. So the example we're going to take is a loan default prediction. So we will give it input data like, if I took a loan, what was my annual salary, what was the interest rate, what was the duration of the loan, and stuff like that. And then we will predict if I will be a default or I will pay off my loan fully, right? So that's the outcome we expect. So the way machine learning works is you give it label data, so we'll give it sample data with all the input attributes and the real outcome. And then what we expect it to do is identify those trends, create a formula, and when we give it unknown data, like new data, it should predict whether I will default on my loan or whether I will pay off my loan, okay? So I'm gonna walk you through the whole experience. So as I said, the very first step is creating your data or importing your data. Now you can import this data from S3, Redshift, Snowflake, and a lot of other sources. For the demo, I will just load it from my local machine. So we're going to do tabular data. I have 2 files, so I'm going to show you. I'll do loan1 as my first file. I'm going to select it from my computer. So I'm going to do the part 1. It's loading, it's taking a minute. Okay, and then we can preview it. So as I told you, it has the loan ID. This is the column that we are predicting, whether it's fully paid, charged off, or current. And these are the other attributes that will go into it, like the loan amount, the loan term, interest rate, and stuff like that. So this is we call this labeled data, because it also has the actual outcome predicted. So this is what it will use to learn and create that formula, right? So I'm going to create this data set. And you see it's creating that here. Now I have 2 files. I have lots of, in typical real world, you have multiple sources, multiple files, multiple formats, and then you have to manipulate it. So I'm going to just, for demo, I will use 2 files. And the second file, I will call it loan2. Okay. Let's preview it. So it still has the loan ID. So this is kind of going to be that unique key that, joins both of those. And then it has other information, like what's the employment status, homeowner status, whether it's rented or whatever, and then the annual income. So it has some additional information about that same loan. And I'm going to create this. Okay, so it's loading. I'll let it finish its processing. Now, I don't want to have 2 different files. I have to join it and then supply it to my model. So what I'm going to do is basically join the data. And I'm going to drag and drop these 2 options, loan1 and loan2. And then we will tell it how to join it. So we are going to do an inner join, right? So it has to have something in common. And we'll tell it what is the unique key. So I would take the ID here, and then again in the loan2, I'll take the ID. Okay, so now you can see it has combined all of this data. And I'm going to import it. Let's call it combine loan data. I'm going to call it combine loan data and import it. Now in real world, you have thousands of files and they're not as simple. You have tons of data. It's not as easy, but having a visual drag and drop, makes your life a little bit easier. Okay, so we have this combined loan data ready. So the next step, once we have the data ready, you may want to visualize it. So there are ways to visualize your data here, right? So this makes you feel like it's an Excel spreadsheet. If you go to Data Wrangler, it lets you do a little bit more fancier things, manipulation, transformations, and stuff like that. Okay. So once you have your data ready, you're going to start creating the model. So we're going to click New Model. We're going to say Loan Default Prediction, Michigan Meetup. We're going to do Predictive Analysis. Okay, the first step it asks you is, what is the data set that you're going to use? So I'm going to use the combined loan data. Okay, now it is asking me which is the column that you really want to predict. So in our case, it's the loan status, because that's what tells me whether it's paid or not paid. So I'm going to say loan status. And these are the three possible values. Now, based on the data that you supplied and the target column, it basically identified, what kind of machine learning this is. So this is basically category prediction, right? So these are the three categories, and you have to basically predict which one of it will be. So it automatically did that, and you have option to change it. So, typically the recommended one is generally right, but it gives you other options that you can look at and see if they make sense for your use case. Okay, I'm going to cancel it. And then you can do a quick build, and there are two options here. So you could do a quick build, which is like 2 to 15 minutes, and then you can do a standard full build, which is 2 to 4 hours. Now, quick build is going to be quick and scrappy and dirty, so it's not going to be as accurate as the standard model. So in real world, you want to do standard model. For today, I'm just going to, preview the model and do a quick build. We will let it done, and once it finishes, you can actually start predicting. So if you think about the power that you give in the hands of the business analyst. In a typical life cycle, business analyst doesn't have this power. If they use tools like this, they can bring the model to a good starting point and then hand it over to the data scientist to enhance it and make it better. Okay. What I'm going to do is just go to my other models that I have trained before. I'll just pick one. So this is what I had done maybe earlier today or previously. So this model actually predicts 82.94% times accurately. Once it's ready, you can do batch prediction or single prediction right from the UI. So if you're a business analyst, it'll show you all the values you can change, and then it'll show you the prediction whether it's fully paid or it will default. Okay, so it also tells you the feature importance. So interest rate has a high influence on the outcome that you're trying to predict. So I'm just going to play with some values here. I'm going to make this, I'm going to say unemployed. Just 1 year. What was the loan amount? Where is the loan amount? The annual income, I'm going to make it low. So we made 5 changes, and then as a business analyst, I can just see what is the prediction like. Okay, so it says 54% I might be fully paid, but 45% I will not be able to pay off this loan with the data that I gave you. Okay, so it did a lot of machine learning, which typically take weeks or months, in 4 or 5 minutes that we were talking here. Right? So that's what Canvas is. It's totally no code. You don't have to deal with any code. It's just drag and drop options. Alrighty.
I have a question. Here, how did you select the model?
That's the big beauty. You don't have to know machine learning and which model to select. Looking at your data and the target column, it will automatically select the model for you. So if you saw in the previous screen, it said it's a category problem, right? So you're trying to categorize based on the input data. You're categorizing whether they'll fully pay off or will not pay off. So it automatically selected the right models for that.
So is it smart enough to say that the data you provided is not capable of predicting the end result, what you want?
It will tell you how accurate it will be. So like on the previous screen we saw, right, it predicts 82% accuracy. So with the data that you gave and the model that it selected, it will tell you that this is just going to be 50% accurate. This example, it was about 82% accurate.
And where did you specify in your example the final column? Like you picked up the data
Yeah.
from S3, it picked up the predictive model.
Yeah. So when you're building, you tell it what is the target column. So this is what you're predicting. It automatically selected the model for you. It told you it's a category problem. You don't have to know whether it's an XGBoost or what kind of linear regression or whatever it is. You don't have to worry about all of that. It automatically does that for you. And then when you analyze after you build it, it tells you this is going to be 82% accurate. So sometimes this may not be the accuracy that you want, and that's why what we see is business analysts will give this as a starting point, and then you will have data engineers and machine learning, data scientists and machine learning engineers further refine the model and make it real. With low code options, you also get that code ready so you can just start building and reusing that code. But this is like giving a SaaS solution and the machine learning power in the hands of business analysts, so without even knowing, you can start using this. So if you're trying to sell a house, you can get a sample data set on a lot of websites and put the data for your house, and then you can see what the house value should be, and then put it on the real estate websites, as an example. Right? But great questions.
Can you take this built model and all the transforms for the data and then readily deploy that? So you can hit an API and have it take your inputs and then automatically give you a result back?
Yeah, so this predict is exactly what it does. So it lets you do a single predict, so one at a time, like an API call.
Yeah.
Or batch prediction, you give it a file and it'll give you the outcome for all the rows in that file.
Yeah, as I'm thinking about how does this wire up to a broader solution?
Real life, I have seen a lot of our customers use low code options that we talked about. So Data Wrangler, Autopilot, and Jumpstart models. It gives you a good starting point of code. And then data scientists want to look at it, want to enhance it, but it saves them a lot of development time up front. And that's what I have seen very common for really mature customers who are trying to really solve true business problems. This is more intended for business analysts. They have these, so typically data scientists are really busy and oversubscribed, and business analysts keep having more and more requirements for them. What this does is shift easier problems into something like Canvas so business analysts can solve themselves, and then go to the data scientists for really harder, meaningful problems where you need data scientists. So that's why we came up with something like this.
Okay.
So if you're a mature organization, I totally see you using low-code options, and this is for your business analysts.
Makes sense.
Great questions. Okay. My favorite topic, we talked about all the low code, no code options, a little bit about generative AI, right? So at Amazon, we see AI, everything happening around Gen AI to be really a step function change, a transformative change in the industry, right? And we kind of compare it to the world of early days of internet and web browsers. That's what actually inspired us to create Amazon.com, I don't know how many years ago.
Yeah, 2 decades ago.
Yes, 2 decades ago. And when we were, when we went live with Amazon.com internally, we started building core capabilities for data center and infrastructure as a service. That's what gave rise to AWS, right? And if you see what our customers, all of you have done with cloud, it's an enormous transformation. We really think this is that next game-changing technology that has potential to transform a lot of businesses everywhere. We are very bullish about this. So all our businesses, devices, stores, Amazon Go and all of it. And again, everything we do in AWS, we are very hopeful that this is really going to be game changing. Okay. So, just setting the table, right? Any technology transformation like this typically follows this S curve. You would have seen, as I give you examples about internet, iPhone is another one. So it typically follows this S curve for the capability. A lot of people really think we are probably here or here. And it's all because of the excitement, and the speed at which things are moving. My 2 cents is, I think we are here just at the early stages, and I see a nod here, but I completely agree. But we are very excited to extrapolate. Like, we're at the inflection point, so it's fun to extrapolate, and exciting to extrapolate what our customers will really do with this technology to transform their business. Every experience that they have internally, and also the experiences that they offer to their customers, right? So I know a lot of you are new to ML, and probably I should have done this as my first slide, but sorry. So what is ML? It takes simple inputs, like we saw in the loan example or Titanic example. It learns the trends from the data that you supply. And if you give it a lot of examples, it will develop a kind of a mathematical polymetric or a formula. So if you give it some unknown data, it will give you an output, right? So simple examples, like you give it a lot of the attributes about the loan, whether this loan is going to be a default or whether they'll pay off on its own. You give attributes about the house, and you predict the price of the house. So there were simple data attributes and simple outcomes. And this is what machine learning has been for 20 years, right? It can do all day long. Now, with all the effort and work, it gave rise to deep learning, which was giving it complex inputs. So volumes and tons of documents, not just data, like structured data, music, video, video, things that we record here, audio, etc. But the output that it would predict would still be simple. So I give it an image, and it would be able to predict whether it is a cat or an elephant, right? It's a simple output. The next evolution that we are seeing here is the GPT, the generative models. They take complex inputs, so tons and tons of text data or image data or video and audio, and they produce complex output. So ChatGPT can give you intelligent responses. It's not just a yes and no or a binary prediction. It can summarize text for you, or it can, these days it can write a blog for you and things like that, right? So you give complex inputs and you get back complex outputs. And the best thing is you can give it your organizational data, your industry data, to make it useful to solve your business problems, right? And to make this happen, it needs petabytes of training data. It needs thousands of hours of GPU, and it needs billions of those hyperparameters that define the knobs that you have returned. And that's why it's not easy, right? It's not always easy to do this. But that's essentially why it also has the value that you're seeing these days, right? With all the excitement. What are the use cases that we see? And I would like to hear from you, like if in your companies you're seeing some discussions around generative AI, I would like to hear from you. But I'll tell you where we internally and with our customers see people using generative AI. So the very first one is creative output. So things like writing a blog, or writing the first draft of your email, or writing the first set of code like we've been seeing today. So it'll give you that first draft, remove a lot of undifferentiated work, but then you use human intelligence for the differentiated work and take it to the next level, right? The other thing is behind the scenes things. These are not as fancy as this one, but where you have internal search, like one of our customers, they had tons of documentation, legal documentation, financial documentation, and their back office was just so inefficient. So they kind of used, For all the knowledge repositories, they gave it to the model, and the model now gives them an easy answer looking at all the data for the information that the employees are looking at. So then employees get that information faster, and they're able to serve the customers faster. When you need recommendations, like on your Amazon.com website, when you want to recommend, you buy these things, and now you want to recommend these things based on your pattern, right? So wherever you have like search or recommendation or summarization type of things, we are seeing generative AI being used, or will be used. New domain exploration. This is like, you are introducing your product to a new customer, and he's trying to learn your product through question and answers. Or you have a new hire, new employee. He's trying to learn more about the company through a chat, GPT type experience, or a Q&A experience, right? And the last one is really the fanciest thing, like the sci-fi, where internally at Amazon we've seen a lot of success. We've been doing it. So it's taking complex things, like think about how many orders we process at Amazon.com, the supply chain and the fulfillment. It's a complex task. The forecasting is a complex task. So generative AI makes those decision making a little bit easier. Now, you cannot just rely on the models. You need the human review and oversight to really have meaningful outcomes, right? So these are the typical use cases we are seeing. And again, this is going to evolve. We are at the tipping, like the inflection point. A lot more is yet to be seen. Are you guys having any discussions in your organizations about this? Like any use cases or anything you would like to share? Or your personal thoughts on this?
I'll take the box, Joan. I think I'm impressed by how many creative ways I find to use generative AI in my day-to-day workflow, all the way from writing code, preparing for a podcast, preparing for calls with customers. So I've been, I found that if you give it what I would call more like broad common knowledge, you can avoid some of the hallucinations. But yeah, I think in terms of where it's going, like I think if you need to find ways to use this technology so that you can kind of get on the wave while it's here and accelerate your ability to be productive. So excited to kind of dive into some of these Amazon tools that I haven't really had a chance to play around with too much. So great presentation so far.
Well, thank you for the perspective. Anybody else? Are there any questions on the live stream?
Not yet. I think we've got one for the Q&A session after, but.
Yeah, the one interesting thing we did recently was we visited a place and then came back and asked ChatGPT, can you predict the itinerary?
Can you predict the itinerary? Okay.
Yeah, what itinerary, if I had to visit this place, what would you recommend? It was pretty close, so that was pretty impressive. But at work right now, it's little, people are on this bandwagon, but obviously we are not supposed to expose company data, so that's one thing.
Let's talk about it, and that's where we'll transition to where I'm going next. But great call out. And so what she called out for the security concerns about exposing your data, it becomes available to all these models. That's of paramount importance to us in Amazon. Like we take security's job zero for us, more important than any other priority, and I'll talk about it a little bit. So here's our take on this technology, right? So we think the future is here, but it's not evenly distributed. This is a quote from, I think, William Gibson, and I stole it. But really, we don't want machine learning to be just with large organizations or governments who can afford it. We want to make it available to everybody, all organizations of all sizes, and even individual developers and stuff like that. So, as you've seen today, although you were new to machine learning, and I struggled a little bit with the demo, but it is relatively easy, even if you don't know machine learning. I hope you got a feel of how easy it will be. If you spend a little bit more time, you will get it, right? So we really intend to make this very easy for our builders, for all our customer builders, right? So that's the very first thing. The second thing is model selection. For some new technology like this, we don't want to be restricted like a lot of other companies are doing with one model. We want to give you as many options as possible so you can exploit what works best for you. So a lot of our tools, we have not only just our models, we call our large language models Titan models, Amazon's Titan models, but we also have like our models from our partners like Anthropic, AI21, Stability, IO, etc. When we are in early days, like for a technology like this, having more flexibility and options is always the best to figure out what really works well, right? So that's our philosophy. The most important one is security. So every company, just like you said, doesn't want to expose their IP or their data to anybody on the public, right? So with ours, you get those foundational models, but then you securely in your VPC, you train it very privately and securely in your own environment, and that data doesn't go anywhere else. We don't take that data, we don't store it, we don't use it for fine-tuning or training our foundational models. Your data is yours and it remains in your VPC. The way it has been architected under the hoods, it's not even possible for things like data exfiltration or IP loss or any of that. So we take that very, very seriously at Amazon. So all our products are built with that mindset. And I forgot to call out one thing, making it easy. To your point, you asked a question, can I have an API and I just give it my data and make it happen? That's exactly what we are doing. So what you're thinking is what we have heard from customers, and that's what we're giving back to the customers. And just like everything else, we want to make it low cost and low latency so it is affordable and everybody can really use it. So that's our philosophy. We talked about a lot. SageMaker has already existed, and that is our machine learning platform we have for so many years now. But these are some of the new services that we've launched for generative AI. So Amazon Bedrock is that API experience, right? So it will have these foundational models, it will have an API, you just give it a little bit of your input data to make it useful for your business, and then boom, it will be completely serverless, it will just have an API that you expose in your applications, right? The other thing is we have Inferentia and Trainium chips to make it, cost effective. And these are purpose built for training the models and doing inferences real time. So cost benefits, latency, and all the good stuff. This is the infrastructure innovation. And then we're also doing, making things easy by services like Code Whisperer. These are abstracted services. So if I'm a developer, I don't know if anybody here is, it is like your companion, and it'll give you ready code as a starting point, and then you can evolve and develop and enhance it. By the way, this is available now, Code Whisperer, and it is free for developers or individual use. So it supports a lot of common languages like Java, C, C++, etc. It works with Visual Studio and a lot of common IDEs that you have. It is also built in with our studio and all the features that we saw earlier today. Okay. So these are the things that we have for generative AI. If any of your companies are interested, please reach out to us. We'll be more than happy to help you. And I want to show you, even if you go back and if you don't want to expose your private data and still want like a ChatGPT type, where is my mouse? Can you guys see it? Okay.
I can see it in the middle of the screen.
Okay, thank you. Okay, so we have these Jumpstart Foundation models that are available for you right now. So let me just pick one. And we give you a playground. So if you want to so this is from one of our partners, AI21. So as I told you, we have models from our partners and our own models. And if you look at the playground, you could give it some sample and then ask it to do some fun stuff for you. So I'm going to say, these are some reviews that I just, I'm going to put some reviews that I copied from Google and see if it can summarize the reviews. Okay. Okay, and let's see if it generates it. let's do summarize reviews and then generate text. So I gave it some sample reviews from Google, and it's so small I should have given you time to read it. And then it generated that this tiny place is delicious, it has friendly service, but limited parking. So you give it a lot of text and it intelligently told you the summary, right? So I just wanted, these foundational models are available right now. If you are a data scientist or machine learning, you can use them now. You don't have to wait for Bedrock. Bedrock is not GA yet, but it will be soon. These are available right away for anybody to use. And like the biggest thing I want to really highlight is we give you flexibility. So you have models from Hugging Face, AI21, Cohere, Anthropic, and even our own model. So we also have Amazon models, right? And by the way, this is just like Jumpstart. So or before generative AI, we had computer vision and natural language processing models, and now we have foundational or large language models for generative AI as well. Okay. Alrighty, back to the slides. And I know we are, how am I doing on time?
It's about 7:40.
We have until 8?
Yeah.
Okay. You heard a lot today. A lot of our customers always ask us, okay, where do I start? So what? Okay, I have all these tools, where do I start? So I'm trying to simplify this. The very first foundation for ML to be meaningful is your data. So if you don't already have a data lake and your data strategy, that's where you would want to start, right? Once you have that, and again, this is very focused on where you start for Gen AI, but it applies to any AI ML. Try to explore and experiment, because everybody is exploring. There is not like a set prescriptive path available for your business to be successful. So we encourage experimentation, but in a safe, secure, private way. We recommend you second the data science team if you already have one, or if you don't have one, think of creating one, so they can specialize these models for your business and your domain knowledge. Like ChatGPT is available with all the tons of data that people are using and from the industry, internet, and all of that. How do you make it useful for you with your own data? So that's where you would want to start. We are always here to happy to help. Anybody, if you are already AWS customers, you have your account team, reach out to them. They'll be more than happy to help you. And then this is one of the most important things. Some people just experiment or do things for sake of it. We ask you to find a meaningful business use case. One of the things I did with my customer is we did an overview of what generative AI is and what Amazon offers, and then we said, let's do a Shark Tank type thing. So have your employees give ideas. Let's have the executive in the Shark Tank panel, and then pick one use case that will move the needle for your business and do all of this effort to solve that problem. Right? That way you're not just doing things for sake of it, and then it'll be lost. You won't get funding and all of that. If you work backwards from your customers or your business, you're going to have larger success. So that's where we recommend you start. This is just my parting things. Before I forget, I kind of want to, so today was a lot of theory. Nick talked about the lab. I just want you to know that June 22nd, 6:30, we will have a hands-on lab. It's not in person, it's all virtual. You go to the same Michigan Meetup website and sign up for it, or RSVP, and then you should have a link to get into it. We can open it up for questions, if there are any in the live stream. Any
Not
questions?
Yet, but there's also a slight delay between the live stream and in person, so it might take a second.
Yeah, and while we're waiting, I just ask for a favor. You could just scan, like QR code this. It will get you to a survey. We really work backwards from all the customers, and your feedback is very important to us. in anything we can do to make this better next time, we're all up for ideas. No questions?
Not seeing it yet.
Yeah, we can hang on here for like 5 more minutes, otherwise we can.
Just type it.
Okay.
Charlie, if you want to go ahead and ask your question, you are more than welcome to.
Is it loud?
Yes.
Or
No questions?
should I turn myself down?
Yeah, we
No, you're good.
Here for like
Oh,
5 more
okay.
minutes, otherwise
All right.
we can-
Okay, thank you. I just sort of a question on how these simple tools can help you avoid model misspecification. And one of the things that prompted me to think about that was the Titanic example.
Yeah.
Should I turn myself? Can you hear me now?
Yes,
I'm hearing.
there's kind of an infinite loop because the live stream is lagging.
I'll stop.
You're good.
It doesn't. Okay. All right. Bye.
Bye.
Simple tools.
Oh, that was funny. I don't, maybe I can send him an email or respond to him
Okay.
after. Did you get who the person was?
Yes, it's Charlie Anderson.
Okay, so I'll look on the people who signed up and I'll reach out to him.
Okay.
You can just have them mute their speakers, and that would avoid that.
Oh. Well, no, it's because my computer is having the live stream play. Does that make sense? Yeah. We have a feature.
We're time traveling.
Eventually.
How advanced we are.
Yeah.
Well, I want to thank the Right Brain team for hosting all of us here and continuing this. I was talking to Jamie, and he said this has been going for 13 years. That was amazing to me. I wish I knew this a little bit earlier.
Yeah, we'd love to come out to Detroit and do a meetup out there.
Yeah, we could really seriously think about it, and maybe we make it a half-day event for those who can come earlier and give them a little bit more value.
Charlie.
I think I have one more question. If you,
Yeah.
So my question
Is so I've been in the trenches with dealing with some challenging data and trying to clean the data. I mean, you talk about it and it's you kind of breezed over it, but that can be a real challenge. And I've worked with orgs that just can't get it right. Like the data's up, data garbage in equals garbage out. So I guess what are some of the pro tips or strategies, any insights you can give to like, how do you actually go from having maybe all this disparate data sources with inconsistent data to a nice pristine data lake?
So that was a meetup topic right there.
Yeah.
We can actually have a meetup on that, and I'm very passionate. The very first thing I see our customers customers may get into is analysis paralysis, right? So you try to get all the data from all the sources without really thinking about what business problem you're trying to solve. So the first thing I would do is work backwards from your business problem that you're trying to solve, right? So what is that business problem that is going to move the needle, and then work backwards from where you can get data and how you can clean it and prep it, right? If you just say, okay, let's get everything, tell me what all data you have, and then I'll figure out what to solve, then you're just spending cycles on technology efforts without any business value. You're not going to get funding, investment. You're not going to get executive support, right? I have seen a customer spend 3 years, circling, building an ivory tower data lake, which still nobody uses. So you have a perfect data lake, but nobody's using it. So that's why I say start with the business problem first. The concept about how do we clean the data, we believe in making your data governance very lean and giving more power to the producers and the consumers of the data. So your governance or a centralized team should really set the SLAs or expectations that, hey, if producer A, you own this data, you must make sure that it is updated at least every 4 hours, right? And it has this format or that format. So it's kind of like a contract that you have, and you hold them accountable to make sure they follow that contract. Likewise, on the consumers, try to give more power to the consumers on how they want to use the data and how they access the data. What I see our customers do is there'll be one central data lake team trying to do all of it, making it very complex and slow down things without seeing business value again. And we've learned this a hard way too through our Amazon marketplace. We have thousands and thousands of data sources, producers and consumers. And it's a real challenge if we have one central two-pizza team to do all of that. So we still have a central governance team, but more power to the producers and consumers. Like distribute that, shift that burden more on them, make them accountable, and they can move as fast as they can. Otherwise, you're constrained by that central team and how fast it can move. Second is, skills is another. What we have seen is you start these technology projects without a business, and then you may not have the right people and the right skills on the team that you're working on, right? And you may not have the right tools. That could also be one of it. But we've seen skills being, a blocker for a lot of our customers, right? So having the right skills, data engineering skills on the team, creating that automated pipeline, if you will, focused on solving a business problem will get you faster. I know I didn't give you a direct, but I hope I kind of gave you pointers.
It's very insightful, actually, and I think it echoes to some of the experience I've had where they kick off this initiative at the high level and they start, well, we got to get all the data from Salesforce, we got to get all the data from NetSuite, we got to get all the data from this thing, we got to get all the data from this legacy thing, and you just start pushing it into a big pile with and then it just goes nowhere. So it really resonates. So wish I would have had you in the room when I was working with some of these orgs.
This gave me an idea for a next meetup topic if we do it in Detroit. I really have a lot of my colleagues who really specialize on data, and they'll have a lot more insights to share. So I would like to, if you guys are interested, we can take this as a next topic. I think everybody deals with data, no matter what your role is. We all have to deal with data.
Absolutely. Thank you, Ritesh.
Yeah, awesome. Thank you.
Thank you.